Hello all. This is a reprisal of my talk from the 2022 Snowflake Summit this last week. It was a really fun event, and I had a good response to my presentation in a full room. But I saw that quite a few people got turned away, so I wanted to put it out here for those who couldn't come, whether it was because the room was full, or if you couldn't make it to the summit this year, or because it was just too early in the morning. So without further ado, I'm going to shrink myself down a bit and get going. Yeah, here's your generic disclaimer. Feel free to pause. But to kick this off, I'm going to first run through a quick summary of my company's Snowflake story. Quote Wizard is a two-sided marketplace for insurance. So if you've got a person here who just bought car insurance and just bought a car and needs insurance, they can come to us and we'll say, yeah, we know some guys, we'll hook you up. So the customer gets to see competitive quotes and the insurance agent gets high quality leads with less marketing dollars spent. So everybody's happy. From the Quote Wizard perspective, that user could have come to us from our website or from an ad or from a call center or from another insurance company that didn't want them. So we have all these different systems for gathering these leads, and then we send them to agents by transferring a call or by sending the info to an API or to a dashboard, all depending on the agent. So we have quite the web of applications and data to make that happen. But historically speaking, those different pieces, different applications, don't all talk the exact same language. For example, one system might get a refund and create a negative revenue record. Another will take that revenue or that refund and update the old revenue record to zero it out. And another will just flag that record and expect business reports to do the logic. So anything at a business level was inconsistent and required a lot of hunting and collecting and manually piecing together data from these different and often slow processes. And that was affecting our bottom line, in particular because on any given day, we're trying to make tweaks to our marketing strategies, and the faster that feedback loop is, the faster we can adjust. So many of you may recognize this as a situation that's kind of screaming for a centralized data lake, source of truth, and a data warehouse for reporting. And we picked up Snowflake for that. When we were getting our designs and feature requirements together for this new system, we kept hearing one particular comment over and over again from our execs and marketers. We need real-time, low latency, up-to-date data. But they were even willing to make compromises on fancy reporting features and history and query speed. So we counted that as a blessing, try to get them what they want. So I'm going to skip ahead a couple of years now, and we've taken this big mess of a data ecosystem, and now we still have that. But in addition, we've hooked all that data up to feed into a data lake in Snowflake. And all of these different arrows here that feed into the data lake are some variation of streaming, frequent incremental loads, live data. We don't have any big slow batch processes here. And each of these different processes has different pros and cons for making that data low latency. From there, we transform the data within Snowflake to conform and standardize all those crazy, wacky business rules into a data warehouse. And then we put Power BI on top of that. So we do have a couple steps here that kind of inherently introduce latency. There's no such thing as truly real-time data. But the whole thing generally keeps the time between a sale happening in one system and that revenue showing up in a marketing dashboard to under an hour. And because it's a common enough question, we our throughput of this system per day is around 2 million records per day. All right, so I'm David Garrison. I already kind of mentioned that, but I've already given a rundown of our system, but what's this talk about? What am I here for? Well, I've been working in Snowflake for a little more than 3 years, coming up on 4 even. And I tend to work as far back behind the scenes as I can manage. I'll sometimes make the comment that I prefer not to know anything about my data because I want my pipeline to work for whatever gets thrown at it, whatever data comes through it. Of course, every data scientist and analyst knows that their data is very important and needs special consideration, and often they're right. So that only gets me so far, but I appreciate the challenge. And before I continue, I've got a couple links here. Feel free to look at those. I've got the slides up there and some scripts and things that I'll be referring to. But this talk is not a case study to show off the cool pipeline that we built or a full tutorial on how to do it yourself. And I don't have one neat trick that will save your company millions. I'm here to tell some stories. I think that lessons are more memorable when they come from a story rather than you should do this. There's a reason that we have Hansel and Gretel and various other fairy tales rather than, hey kid, don't wander into the woods alone, please. And I'm also a big believer that you learn more when you make mistakes than when everything goes perfectly. And oh boy, have I made some mistakes. So I wanted to share how I've learned from my experience using Snowflake and hopefully throw out a few nuggets of wisdom that will help some of you avoid those same mistakes. And throughout, we'll kind of weave through how my system manages this streaming and incremental throughput. I was closely involved in all of these stories, and for consistency, I'll be using the pronoun I for much of this talk. That's partially for narrative purposes and partially to avoid throwing anyone specific under the bus, and definitely not to steal all the credit. I really do work with a full team of people who are equally capable of making mistakes. And there was audience participation in the original talk. I'm going to kind of skip through that on this version of it. But back to the beginning of this journey. I've been tasked with building out a data lake with low latency. And we'll come back to streaming data and snow pipes, but we have a lot of data that doesn't make sense to stream, like application databases. So I do some research, and I learned that a pretty normal pipeline into Snowflake looks like a file data shows up in a storage account or S3 bucket or whatever Google uses, which then Snowpipe picks that up and loads that into Snowflake. And then you can have a task and a stream for some post-processing of that. But back in my day, we didn't have streams. That wasn't a feature yet. Nowadays, those streams are an awesome part of making loads run incrementally. But I had to build my own. So I built an orchestrator Azure Data Factory pipeline that creates a file and then truncates a stage table to account for not having a stream to do the incremental bit. It then runs a copy into statement, which is what a Snowpipe does, and then it triggers a stored procedure to do some post-processing, which is what a task does. So this is really why I'm not going to regale you with my amazing pipeline. It's really a tweaked version of a very standard paradigm for Snowflake. And it's not even hip with the cool jazz that kids are doing these days. And just like an old man, I'm going to be spelling out the morals to my stories. So I wanted to call out here that streams are a super cool tool for doing anything incremental. It's a cool tool. You should check them out. It's kind of the change tracking, change data capture, temporal table feature that I've wanted in every other database that I use. And I also find it's very useful to, when I'm looking at new third-party tools, a lot of them are building in more and more incremental features, and I find it's a very useful thing to ask about and help me learn about the tool that way. It's just a good feature to know about too. But if you're going to build it yourself, like I did, one of my saving graces was all the logs that I had it spitting out at every step of the way, which was very useful for troubleshooting and enabling self-healing processes to make it much more robust, since we had all the logs of what was loaded when. However, I built those logs within Snowflake. Some of you may see where this is going, but this pipeline logs a number of different things. Ultimately, it was hitting Snowflake 5 or 6 times per table per load. The details aren't terribly important, but this worked great in the prototype, and it worked great when we built it, when we deployed it. But as we ramped up and added more and more tables to this process, we started to see some issues. And I'm going to kind of skip past the quiz part of this, but you can pause for a second, think about it if you want. We had an error come up that was, we had too many connections to the table, the log table. I don't remember the specific phrasing of the error, but it's not an error you should see very often, because you're generally not supposed to use Snowflake this way. At least that was true up until the summit, where they announced a new feature called Unistore Hybrid Tables, which adds an OLTP use case to Snowflake. It's of course in private preview right now, so I haven't actually gotten my hands on it yet, but I'm excited to try them out and try these sorts of use cases for them. But nevertheless, in your standard Snowflake tables, when we were doing this, I went back to dig through the documentation, and I found that in the documentation, it pretty clearly states that when you're loading data into Snowflake, the optimal file size is 100 megabytes compressed, 100 to 250 megabytes compressed. Although back when we were doing this, it said 10 megabytes, but that's not particularly important. Either way, if you copy a 100 megabyte file into Snowflake, it takes a second or two to load that file. Snowflake builds out micropartitions, updates metadata, does some magic behind the scenes, but it only takes a couple seconds. But if you send that same volume of data 100 bytes at a time, like with individual log inserts and updates, for example, or the metaphor of children throwing paper airplanes, I suppose, those batches still take a second or so each. And that delay is caused by Snowflake still needing to rearrange those micropartitions and update metadata, no matter how small that changes. So that feature that makes Snowflake awesome at handling these large batches quickly bites us here when we're using it this way. And you can't make your warehouse big enough for this. It's not the queries that are slow, it's the backing up of these queries against one table. So now I have built out this fancy pipeline in our fancy new database tool in Snowflake, and we're moving a bunch of data with it. And now I have to go and tell everyone, hold on, that thing that I just built for migrating data, yeah, I need to go migrate data off of Snowflake. So switching over to another database was a little bit of a pain, but it was just a migration into a database that's better designed for this purpose. So now I've built out this, I've got these logs going into a table designed for being a logging table. And we've gotten up to that 120 tables and haven't yet run into another big bottleneck. It runs just about as fast to load those 120 tables as it does to run a few. They're running in parallel, and we're running this every 10 minutes. So even though some of those tables are very large, they get batched into small enough chunks that we rarely have any issues. So of course, my lessons here, use a tool for how it's supposed to be used. In particular, be aware that when you're pushing on boundaries, it's a good thing to push on boundaries sometimes, but you do so at your own risk, and you should be aware of why those boundaries are there in the first place so that you know what you're pushing up against. And this is going to be a little bit of a recurring theme here. So now I've got these tables, these 120 odd tables, loading into Snowflake. And I was loading this data using JSON, putting data from the source table, all the columns from the source table, packaging them into one big JSON column in Snowflake, because I'd heard about how great Snowflake is with semi-structured data. I had done some testing with this, parsing the data and querying it directly, and it worked great. I was sold on it. I threw some views on top of these tables so that our users could query them with the normal SQL that they expect, but with this magic of semi-structured data under the hood. Now, after not long at all, we had some performance issues here with some queries and not others. So I'll pull this up. You can think about which queries it was that we were having issues with. And yeah, we were having issues with queries that had date filters in particular. And after going again, hunting through the documentation, right there in the details, it mentions that dates and numbers in strings specifically aren't able to really take advantage of Snowflake's internal management of the data. These are treated as strings because JSON doesn't have data types for dates, and if you put quotes around your number, it treats them as strings. So Snowflake doesn't know any better. It can't build up its metadata and do its efficient optimizing and micro-partition metadata management. And also, there's some notes in the documentation about nulls and how if a JSON attribute sometimes has nulls, then it also won't be able to use metadata. But there's JSON nulls and Snowflake nulls, SQL nulls, and empty strings that are treated as nulls. So I've had mixed results with this. But nevertheless, that's a whole conversation about nulls that we don't need to get into. This is an issue that still occasionally bites us, these semi-structured columns that don't have metadata. But now we have made it a pretty standard part of our process to columnarize these important columns. And I don't think this is really a super common standard industry term, but I also don't think I made it up myself. But what I mean by that is extracting that JSON attribute, that attribute that has a date in it, into its own proper column in that table with its Snowflake data type. So it takes an extra round of post-processing or a transform in your pipe. There's a few different ways to do this. But once you have that column, as long as you're using that in your views, you'll get that optimized querying features back. And for quite a few of our tables, we actually just columnarize all of the attributes because that's simpler than figuring out which columns are going to be used in your where conditions and your join conditions and your ordering, the things that really take advantage of that metadata. So yeah, the semi-structured data has been great for us. We still get a lot of benefits out of it. If a new column shows up in the source system, that shows up in the semi-structured data without us having to touch anything. But it's definitely worth having this extra step in tables that have structured data in them. You might not want to just treat them fully as semi-structured data, especially when these columns are used in filters and when you have dates. And as a bonus tip, that's a whole extra story that I didn't put in here. I wanted to, it's maybe a little oddly specific, but the punchline is don't parse data in your JSON, don't parse JSON in your data masks. It's a similar issue with these other data types, but it's worse and it affects all data types. You can hit me up if you want to hear more about that. Put it in the comments below. All right. So in a kind of similar vein of query performance and Snowflake internals, we had a big complicated query with a lot of business logic that we had in a dashboard. And it was taking 10 plus minutes to run, which wasn't a great experience. So I did some digging and pulled apart the individual pieces of this query to test what was slow and compiled those individual parts into a final table so that I can compare results, make sure that the results are actually the same. And in the process, I kind of incidentally realized that running all of these individual parts, building it all together, and querying it took less time than it did to just run the query. I attribute this now to the warehouse was probably too small and we had some spilling going on. But there's also something to be said for splitting it apart and helping Snowflake do the parallelization of these really complicated queries. For us, the real takeaway is that it's been helpful to experiment with direct queries inside of views or building out actual table objects. We use dbt for this, which makes it really easy to take a business logic query and switch it from a view to a table to a CTE with another view. Ultimately, it typically comes down to making sure that Snowflake is doing the hard work and that as much of the pruning happens as possible on the Snowflake side before running the query on Power BI. All right, so on to streaming data in Snowpipes. So if you're not familiar, the 5-second version is that Snowpipes are Snowflake's built-in streaming tool. It's perfect for low latency when you've got data that is event-driven, makes sense to stream. So once I got Snowpipes up and running, I did a thorough run-through of our organization with, could we stream that? Could we stream that? And it's possible I went a little bit overboard in some places. Suffice to say, we have a lot of Snowpipes. And so I've had a lot of opportunities to screw up Snowpipes. So I was this time doing my best to follow best practices from the documentation, which says that it's fine to have all of your messages from your various storage containers or buckets feeding a single storage queue, or SNS topic if you're on Amazon, and going to a single notification integration in Snowflake. From there, these messages get distributed to the appropriate Snowpipes, and that tells them to go and pull the respective files into Snowflake. And we had these up and running. The notification integration was handling some impressive throughput, and about 6 months into using them smoothly, we had a new project that was switching over to sending data through Snowpipes. And we started having these test files getting created and coming into the integration, but the Snowpipes weren't hooked up yet. And these integrations are designed to pass the messages along, not to store 10,000 or however many thousand of them. And so that integration quickly filled up and stopped receiving more messages. So all of our pipes stopped getting their messages. These test events were now causing all of our pipes to stop. So, of course, we had an immediate panic of, where's my data? So we get a war room together with all of our DBAs and systems folks and IT and analysts, whoever we can find in one big conference call. But once we had stopped that flood of bad messages, the pipes started working again. They started flowing through again. It was great. but our pipes had missed almost a full day of new files. So I had to put together a script to run alter pipe refresh on all of our pipes. This is a command that tells a Snowpipe to look back over the past 14 days and load any files that were missed. And after a couple of syntax errors and failed deployments with everybody watching, we had our data back in our tables and we're moving along again. So we've definitely had to use this alter pipe refresh tool a few times before and a few times since. It's a very useful tool to have in your back pocket if you're managing snowpipes. I do want to call out that the documentation explicitly says that it's intended to be used for one-off fixes and not as kind of a standard expected part of snowpipe usage. And just to kind of call it here, as much as we were trying to follow best practices, in this case, we were maybe treating them as a little too ironclad. So after we've all signed off from that war room, I've got an action item to set up a test notification integration so that test data won't affect production. Not that we would ever make the same mistake twice. So I created a new integration specific for our test events so that any future issues there won't affect our production events. And I hooked it up to our storage queue, and immediately all of the messages started going to the new notification integration, the one that was meant for our test events. Apparently, these integrations are not designed to have two of them hooked up to the same queue. So we get a war room together, and everyone's looking at me here. And I didn't yet have the hindsight of what was causing the problem, and it wasn't just fixing itself magically this time. So I did what any panicking engineer might, and I suggested the nuclear option of just recreate all the pipes and the integrations. I did have everything scripted out in source control, so it was a bit of a pain to put it together and make some syntax errors and deployment failures while everybody was watching, but we did get it back up and running. I don't expect anyone here to come away with all of the intricacies of storage queues and notification integrations and snowpipes. I still don't trust myself to keep them all straight. My real lesson learned here for me is that for anything that you do at an account level, it's really helpful to run it in a fully separate account first, which seems kind of obvious in hindsight, I suppose. The organizations feature is a really useful tool for this. You can spin up multiple accounts for this sort of testing without any extra costs. Of course, back when we were doing this, organizations weren't a feature yet, but it's definitely something worth checking out. So we've got our war room breaks up. We're all good, right? Well, right, but our pipes have been down for a while again, and so we needed to get caught up again. But this is old news. We already have a script for this. We already ran this. I didn't even have to make syntax mistakes this time. Just run the same thing, get our data back. So I'll give you a second to think about what might have happened when we ran that alter pipe refresh again. And as a hint, I had to recreate all of our snowpipes when we chose that nuclear option. And I'm going to jump to it. Yeah, we had duplicates. The first thing that we actually saw was that the revenue from our previous 2 weeks was doubled. So we all celebrated our newfound wealth. But it turns out that when a pipe is recreated, the history of what it has loaded in the past gets wiped out, the copy history. So when an alter pipe refresh goes out, it loads all files from the last 14 days that haven't been loaded. But it doesn't know it hasn't been loaded, so it pulls in everything and duplicates that data. At this point, I think we just used the same conference call for that more room. A lot of our pipes were actually robust to dealing with duplicates, just because of other source system duplicate issues. But there was manual cleanup to do. We at least didn't keep the war room open for all of that. One specific lesson I really want to call out here is that the Snowpipe metadata, no, I can't reach that far. The Snowpipe metadata in the Snowpipe tables, in the Snowpipe syntax, you can add these metadata columns. It's like metadata $ file name. And I would definitely recommend, if you have pipes and you don't have this, or if you're going to do pipes, to add these metadata columns. I was able to use these to write a script that could go through and compare row numbers and file names to automatically detect duplicates, and compare the list of files that have been loaded to the ones that are on the storage account, and reload the ones that were missed. That script is up on my GitHub as well, which I'll make sure to include that link. It's next to the slides. And then I also want to call out that AlterPipe refresh does have a parameter to prevent this issue. You can put in a time span to tell it how far to look back. So this was not Snowflake's issue, this was our issue. We now include that parameter whenever we're using this function, whether we need it or not. But and of course, yeah, spare some time for testing, even if you've got people looking over your shoulder in a conference call. There's no more important time to be rigorous with going through all of your deployment processes and checking your syntax and compiling it. But it is worth mentioning that this series of Snowpipe stories, at least, was over the course of just a couple weeks. It was a very rough couple of weeks, but I've been telling some of my worst stories from my past few years of using Snowflake, but I've left out a lot of time in between when things went pretty heckin' smoothly. We're still regularly onboarding more and more data sources, building more and more fancy reporting on top of it. And kind of as a summary, we've got our data lake down to between 5 and 15 minutes. It depends on the source. Some are faster than others. And I know our data scientists and people querying this directly really love this because they have the most fresh, up-to-date data most of the time. And there's an extra little bit of processing that happens to get this data into our data warehouse. It's actually more like 15 to 45 minutes latency to get our data into our reports. But of course, there will always be somebody who wants it faster. But of those compromises that we were willing to make for low latency, we ultimately didn't really have to cut anything out. Our queries are faster, our reports have more fancy features, and people can query the data directly using SQL that they already know. And we've been able to build in a lot of knobs and dials for managing our pipelines, both in terms of cost and performance, which has been really helpful. In general, the Snowflake cost has been a lot less than our previous system. And in particular, the incremental cost of making our pipelines run incrementally have been basically zero. Snowpipes are based on usage. We use a small warehouse that's always active for our random tasks and jobs and processes. So there's not much extra warehouse cost for having this incremental pipeline running compared to a once per day batch. Of course, there will always be somebody who wants it cheaper. So occasionally I like to put them in the same room as the people who want it faster and let them duke it out. Yeah, I'm not sure if this is me here or Snowflake in the middle. Probably Snowflake, but you can choose which metaphor you prefer. And if there's one slide to, I suppose, take away from, I've got my recap here. So just as a quick review, it's been really helpful throughout my experience using Snowflake to read the documentation. and learn how the tool is supposed to be used. Of course, it's hard to do all of that work up front. You're going to make mistakes, but the Snowflake documentation is pretty good uh, and has generally pretty good best practices. Um, and for semi-structured data specifically, it's a super awesome feature, extremely useful and flexible. But of course, not all data is actually semi-structured. So sometimes it's useful if you have the structure to pull out those columns into proper Snowflake table columns. It will improve your metadata. And then for doing work on these account level features, account level changes, integrations, even sometimes making changes to your grants and roles. Set up a separate account using organizations. It'll be really helpful and save you a lot of trouble with making mistakes and affecting production. Check out streams, super cool feature. Alter pipe refresh, a good one to have in your pocket. Be a little careful with it. Learn some of its ins and outs first. Test it in a separate account maybe. And then for your dashboards and reporting, do what you can to have Snowflake doing your heavy lifting on your query processing, optimization, pruning in advance of sending that data to, say, Power BI in our case. All right. And then I have this fun list of extras that didn't make their cut into the full talk, but you're welcome to skim through this. And I do have some of these related scripts and things in my GitHub as well. So feel free to check that out and grab the slides, steal things, do what you want with them. Obviously, questions aren't going to really work here, but feel free to put questions down in the comments. I'll do my best to respond to everyone. And I don't know what would happen if you actually scan this, but anyways, thanks for listening. I hope to see you at the next event.